Hi guys, today we'll be looking at lesson 4 of our 4 lesson series for AQA Psychology A level. Today we'll be looking at probability, significance and statistical test exam question practice, essentially just bringing everything together. So what have I got first? Lesson 4, we have a full exam walkthrough for inferential statistics. In this lesson, we're going to look to put everything together. We'll work through the exact topics, and by the end, you should be able to choose the correct test, calculate the sign test, interpret significance, and write a proper conclusion. So, have this table here. Write this down now, and now pause the video and write this down. Welcome back. So, this sums up everything you need to know for the AQA A level. Yeah, so for the respective data, whether it's related, unrelated, different, or correlated, or categorical, you will need to use those tests. So let's look at this a bit more in more depth with some examples. So choosing the correct test. A psychologist investigates whether memory is better in the morning or afternoon using the same participants. So step 1, ask the 3 questions: difference or correlation. Here we have a difference, yeah, because the psychologist investigated whether memory is better in the morning, yeah. No, nowhere is there talk about correlation, so we have a difference. Data type, because it's so we need to know if it's nominal, ordinal, interval data. Because we have scores, this will be ordinal. Design, do we have related data or unrelated? Well, it says there using the same participants, hence the design is related. So the model sentence for your exam would be: a sign test is appropriate because this is a test of difference using a related design with ordinal data. Always justify your choice, it's easy marks. So let's just relate that back to the table that you wrote down. You can see there, related difference, it was either Sign or Wilcoxon. So hold on, let me just show you this bit. So if it's related difference, it's either going to be the Sign test or Wilcoxon. In the AQA syllabus, you're only required to calculate for the Sign test. So the Wilcoxon is just essentially a more accurate way of doing the Sign test. So let's go to example 2, which is a sign test calculation. So participants were tested before and after a COVID awareness campaign. So you may remember I'd looked at this in previous video. So their knowledge was tested, and I'm going to do the sign test here. So what we need to do is look at whether people gained knowledge or lost knowledge. So from here to here, you can see they've gained it. So that would be positive. Here there was a loss because that before they answered 8 questions right, this time it was 6. So that would be negative. The third one, there was a gain again of +2. The fourth one again was +2. The next one, there was no change. So essentially we remove that person from the data. So instead of having n was 10, so 10 people in the study, now essentially there are 9. The 6th person was a gain of +1, so again positive. Next one, a loss of 3. I'm not sure what they were looking at. So -3, so negative. Again, we've got a +2, so positive. 9th person didn't make any difference, so we remove them. So now our data is down to 8 people. And the third one gained 3, so positive. So for the sign test, we only care about this. Now, Wilcoxon would care about the amount they've gained and lost, but we're not asked about that, we don't need to be able to use that, so it doesn't matter. But that's why Wilcoxon is a better approximation or better test. But obviously, sign is simpler. That being the benefit of it. So we have, if we count positives and negatives, we have one, two, three, four, five, six positives. But we look at this and we have two negatives. So remember, S is the smaller of the two. Now S is 2. So the smaller that number is, the more likelihood that the test was useful. Now, N is the amount of people in the survey. So our N value here is 8 because, like I said, we remove the people where we have ties. So N is 8. Don't skip that bit because it's important to get marks. Yeah, so that is the first part of the sign test, as simple as that. So from that, we have got S is 2 because that was the smaller of the two numbers out of 6, and there were 6 positives and 2 negatives. We picked the smaller one. N is the number of people that we actually used, and that was 8. So now let's expand that. So now we're going to interpret our results. So what you'll be given in terms of significance and data values is this. So what you've been given here will be a critical value of 0. And that's what we're going to relay our answer to. So we got S was equal to 2. Now, if we look at that data, we only had 10 people. From it, we removed 2 and we had 8. So is 6, intuitively, do you think 6 people improving out of 8 is enough to say that the campaign definitely worked? The data, the statistical tables would suggest no. So our critical value is 0. So what they're saying is we didn't want anyone to not make an improvement. Yeah. So because we ignored the ties, we actually had 2 people that got worse. So for this, the data needs S to be greater than or less than, less than or equal to 0, and it's 0. Well, no. S is equal to 2, which is clearly more than 0. Therefore, the result is not significant at a 5% level. The null hypothesis is accepted. Any difference is likely due to chance. So we're saying from that data, 10 people, 2 we removed, so we had 8. 2 of those 8 people got worse. The data doesn't support the fact that the campaign worked. So a nice reminder is for the sign test, small is good. So what I mean by that is this S value, the smaller it is, the more trustworthy the study. All right, next one. Example 4, chi-squared. So if we look at our table, chi-squared is for categories. So a psychologist investigated whether males are more likely than females to walk under a ladder. Chi-squared test was carried out. Now, we're just given the data, we interpret it. So we've got a critical value of 3.84 and a calculated value of 2.981. So that's not what I was supposed to do. So is 2.981 greater than 3.84? No. So it's not significant. So the reason it's getting confusing is now whether it's greater than or less than. So with chi-squared in this thing, you've got your normal distribution. So this area represents what most people would do. So we're saying the critical point here is that bit. So having observed people, that's our critical value of 3.84. So anything in here would be a change, would be a significant change. So since 2.981 is in here somewhere, that means that is just that is a normal expected result. Anything in the tails is unexpected. So because 2.981 is not greater than 3.84, we do not have enough evidence to support the alternate hypothesis. So the result is not significant at a 5% level. The null hypothesis is accepted. There is no significant difference between males and females, and any difference is likely due to chance. So that's why on the chi-squared, we're looking for a value greater than the critical value, because we're looking to see, are we in this anomalous area or region? So next one, Spearman's row. So Spearman's row is now correlation. So a psychologist investigated whether time spent watching COVID news is related to anxiety levels. Calculated value 0.62, critical value 0.56. So what does this data actually mean? So let's give you a bit of a GCSE maths revision lesson. So we've got a correlation. So something like this that would give a clear straight line would be a perfect correlation of 1. Yeah? And something that gave a perfect negative correlation would be -1. So the closer the value is to 1 or -1, the more correlated it is. So if we did something of about 0.56, in reality, it would probably look something like this. Yes, it's like a weak positive correlation. So what this is saying is the calculated value is better than the critical value. So that's why we're looking for the calculated value to be greater than the critical value in this case. And because it is, we accept the alternate hypothesis. So the result is significant at a 5% level. The null hypothesis is rejected. There is a significant positive correlation between time spent watching news and anxiety. Yes, so what will be confusing for you at this point is which way round this goes, which is why I'm trying to give you just an explanation of the maths behind it. Yes, so here Spearman's row and Pearson's, which we use for interval data, they're correlation coefficients. So this indicates a stronger positive correlation than the critical value. Had we got a number less than 0.56, it would have meant that the data was less correlated, hence we're rejecting it, because that is our minimum acceptance point. I know I'm starting to waffle, but I hope that waffle is good. All right, next question. Choosing between tests. Now let's look at a very common question. A psychologist must decide whether to use a Mann-Whitney U test or Spearman's row. So let's have a look at this bit here. So Mann-Whitney is for unrelated difference data, and Spearman is correlation. So let's look at different cases. This should fade out. I'm not sure why it's not. There you go. So key question, are we comparing groups or looking for a relationship? Case 1, let's compare groups. Example, comparing anxiety scores between 2 groups of participants. Well, clearly we're comparing groups in that situation, hence Mann-Whitney. Case 2, relationship. Example, looking at whether 2 variables are linked. So that time we're looking at correlation, hence Spearman's rho. So a model sentence, a Mann-Whitney U-test is appropriate because this is a test of difference using an unrelated design with ordinal data. Whilst for case 2, Spearman's rho is appropriate because this is a test of correlation using ordinal data. So that's the sort of model answer we would be using. So with groups, we use Mann-Whitney. A relationship, we use Spearman's rho. So take time to just pause the video and jot that down. Welcome back. All right, coming towards the end now. So now the final part is about type 1 and 2 errors. Very simple. Again, you just have to jot it down and memorize. A type 1 error is when we end up rejecting the null hypothesis when it is true. So it's a false positive. A type 2 error is the opposite, so accepting a null hypothesis when it is false, which is a false negative. Okay, so that's it. So final bit. So remember the process, choose the test, calculate if needed, compare with the critical value, write a clear conclusion. If you follow that structure, you'll consistently pick up the marks. And yeah, make an effort to learn that table, and that will help you with these questions. I've hoped you've enjoyed the four-part series. See you again soon.